Solving one-step equations using multiplication and division. We'll go through 4 examples here just as we did with addition and subtraction. The only difference between solving one-step equations with multiplication and division versus addition and subtraction is exactly as it says in our title. We're using multiplication and division here, not addition and subtraction. The concept that we have this equal sign that's dividing our equation into 2 parts still holds true. And we still can only do something on the left if we do it on the right or vice versa. So as we look at the first example, we see that we have 3x equals 12. Anytime we have a coefficient or a number in front of our variable, that right now is multiplication. To undo multiplying by 3, you have to divide by 3. We would write that as a fraction. Just put the whole thing here, that whole term, over 3. That says 3 times x divided by 3. If I divide everything on the left by 3, I need to also divide everything on the right-hand side by 3. I am now balanced. I've done the exact same thing on both sides. Unlike with addition and subtraction, we're not looking to get a 0 here. Because we're multiplying and dividing, a 0 would cancel everything out. What we really want is a 1. That's the multiplication identity of 1. So 3 divided by 3 doesn't give me 0, it gives me 1. So what I really have here is 1x equals 12 divided by 3, which is 4. Okay. I don't need that coefficient of 1 though. Just like if you look at example 2 up here with my x, that's really 1x. But we don't have to write a coefficient of 1. So our final answer is that x equals 4. Just like with my addition and subtraction, I can check that by substituting into my x here. 3x, and in this case x is 4, I will always substitute in using parentheses. 3 times 4 is 12, so this is correct. Example 2. Again, I see that I have an equal sign. I know it's an equation then. The left side is x over 2, or the fraction x over 2, which is really division. All fractions are division. So it's saying x divided by 2 equals -1. The opposite of dividing. Anytime I have an x in a numerator here with a numerical denominator, I am going to multiply. I'll show that with this little dot. Instead of dividing by 2, I'm going to multiply by 2. That's going to give me 2 times x is 2x over 2. Just like with my first problem, I have 3 over 3 here. I have 2 over 2 here. That gets me my 1x, or just the x. Okay, I don't need to write this whole step. I'm going to leave it there and just kind of put a line through it saying, hey, we don't need to write that. But what we do need to write is that if I show I'm multiplying the left side by 2, I have to show that I'm multiplying the right side. That's going to show my work that I have balance in my equation. And then on the right-hand side, I get -1 times 2 is -2. My final answer, x equals -2. Double check. If I substitute in, I get -2 over 2. Well, -2 divided by 2 is -1. I'm correct. Example 3 tends to be the example that people struggle with the most. And I made this one extra hard because not only is it a big fraction in front of my variable, but I also have it as a negative. So, start by locating your equal sign and recognizing that it's going to go down that vertical line. I have my 2 sides of my equation now. Anytime you're multiplying by a fraction, so we're putting 2 concepts in play here at the same time. I'm multiplying x here by 3 over 4. Part of us would say, hey, I'm multiplying, the opposite is dividing, and that part of us would be correct. We are going to divide, but what I want you to remember back from your pre-algebra days, multiplying by a fraction change that. Dividing by a fraction is the exact same thing as multiplying by its reciprocal. The reciprocal is when you flip the fraction. So I could say that this is the same as multiplying by 4/3. If I wanted to divide by 3/4, that would be the same as multiplying by 4/3. So on this side, I'm going to multiply by 4/3. The second concept here is that this is negative. The only way, because I don't want my answer to be negative, I want it to be positive. The only way to make sure that this answer becomes positive is to multiply a negative by a negative. So I'm going to actually multiply both sides here by -4/3. What happens is, when I'm multiplying fractions, I can multiply straight across. I get -4 times -3 is +12, and I get 3 times +4 is +12 times x. There's my 1x again. That gets me my x by itself on the left-hand side. On the right-hand side, what I'm multiplying, 15 is a fraction. It's 15/1. So what I'm really getting is 15 times -4. Use your calculator if you need to. That'll give me -60. And 1 times 3 is 3. Now I can divide. -60 divided by 3 is -20 for my final answer. There will be a few practice problems that are similar to that. This one is one of the more challenging types when we are dealing with just that fraction in front. So make sure you pay close attention to practicing the fraction problems. Example 4 goes along with the fact that in examples 1, 2, and 3, we wind up with this 1 in front of our x, because this is not just -x. This is really saying -1x equals 6. There is that implied 1 in front of your x there when there is no number, and since there's a negative sign, it's actually a -1. So now it becomes a problem very similar to example 1. I'm multiplying x by -1, so I take my equal sign. To get rid of multiplying, I divide by the exact same thing. -1 divided by -1 becomes my +1x, or just x. And 6 divided by -1 is -6. Box it in, it's my final answer.